right. This is always fun to do the handheld mic. So welcome. We're going to be talking today about IoT Analytics, spanning from the edge to the cloud. I'm Jason Shepard. I manage our overall IoT strategy at Dell and also our partner program. Here with me, I've got a handful of our partners. I don't know if you guys have checked out the IoT Expo, but you can certainly go learn more about what they do in detail down there. Do a quick round of intros. I want to get a feel for the audience, and then we'll just kind of dive in and explore different aspects of analytics in IoT. So here to my left, I've got Greg Knowles, who's the program director for the Watson IoT Analytics unit at IBM. Been with IBM about 23 years, so seen a variety of different areas within the business. Welcome. Yeah, thanks for joining.
Thanks, Jason. It's good to be here. Thanks, everybody.
Cool. And then with to his left is Giles Nelson, who's with Software AG, runs their in-memory and streaming analytics parts of the business, also responsible for Internet of Things strategy. Welcome. Thanks for joining. Greg Pico with Eigen Innovations, it's a video analytics company focused on manufacturing and real-time quality control, so it kind of brings a different perspective. Overall product management for the offering part of the leadership team.
Yep. Thanks, Jason.
And then finally, we've got John Savage, who's with Action Point, founder and CTO. Yet another perspective from a more of a services or systems integration standpoint, focus on smart manufacturing and a variety of other use cases, and kind of give the perspective coming at it from how do you kind of piece all this together, and the. Well, we've had conversations, is it the last mile or the first mile? But either way, it's some of the hardest parts is kind of pulling it all together in the end. So with that, I wanted to kind of get a feel. So in the audience, I know a few folks from a technology standpoint, but how many people have been actively looking at IoT solutions today? So a couple, maybe three, four folks. What's the sort of makeup? IT decision makers, IT focus. Is that predominantly kind of what we're looking at here? And yeah, okay. Welcome. Okay, cool. So I'm going to run through a little bit of kind of high level on the Dell focus, and then we'll get into some questions here. So. I don't know if you guys have been to any of our other sessions, but Dell here is our purpose is to really drive the backbone of the IoT. So that's spanning from the very, very edge, sitting right upstream of the things with our line of edge gateways and embedded PCs. Certainly, we have a wide variety of tools within the networking infrastructure, servers, storage, etc. We want to be able to be the provider of this distributed architecture and foundation for IoT solutions in commercial and industrial use cases. As part of that, it's extremely important that we partner widely, because nobody can possibly do everything that it takes to go do IoT type solutions on their own. So we're here to go enable our partners to go build out full solutions in a variety of different use cases. It's also not possible to send every possible piece of data directly to the cloud. It's an immense amount of data, immense amount of bandwidth consumed, and there's many use cases where you need real-time response, and things go boom if you don't have that message delivered in time. So you need that the ability to distribute processing and storage throughout the architecture. So a lot of what we'll talk about today is this whole notion of distributed analytics and some of the complexities associated with it. And so with that, I'll kind of move to some questions with the panel, starting with Greg. So I think most of everyone in the room has heard of Watson and the cognitive capabilities of Watson, and seen it played Jeopardy very well and the like. But how do you see Watson, both addressing IoT use cases, but especially at the edge, and addressing some of the unique challenges as we talk about distributed architectures?
Yeah, that's a great question, Jason. So first of all, the point that you made about just the sheer volume of data is something that we're starting to see again and again as these kinds of solutions scale up. right? And when you think IoT, you think cloud, but more and more we're having to think of a distributed architecture. Our IoT division was largely born on the cloud. We have a lot of legacy technology, things that we've enabled for the cloud, put out in the cloud, but it's inherently a SaaS-oriented, cloud-oriented business. And when we started talking to customers, what we figured out very quickly was cloud presents a problem for a lot of environments for different reasons, right? And the sheer volume of data is one of the biggest. We started talking to customers about solutions that were going to scale up to 40, 50 million devices that were distributed, you know, in 100 factories around the world, or individual devices that were going to be, you know, scattered worldwide. And the amount of volume these things would produce quickly overwhelms, you know, the capacity of the network, overwhelms your Wi-Fi, your Ethernet network, and incurs tons and tons of costs, right? And plus you've got constrained networks in a lot of places where you've got cellular connectivity, 2G or 3G, and there's a lot of data that needs to be analyzed. So we had to start coming up with new ways of bringing a lot of our cloud capabilities out to the edge of the network, right? To summarize and analyze and gain insights on the data at the edge of the network, so that we didn't have to send everything back to get that insight, to analyze that data, and then send the results back. And the other point you made about latency, dead on. A lot of environments and a lot of use cases, we can't afford that round trip to the cloud to make a decision, right? If it's a near real-time operational decision, I don't want to rely on that network connection. Could go down. Goes down once a year, you know, whether you like it or not. So you can't have your operations dependent on that connection all the time. So that's what kind of drove us to start looking at the edge and to start thinking about how we package up our cloud technology and bring it to the edge.
Cool. So, and then Giles, like from a software AG standpoint, you guys also see a need to start to kind of drive more analytics towards the edge. I mean, you guys are experts in streaming analytics. How do you see edge computing transforming your streaming analytics and some of the unique challenges associated with it? And how do you decide what to put where, whether it's in the core or in the edge?
Okay, so I mean, to your point, Greg, about, you know, IoT, one thinks of the cloud. I mean, yes, I get what you mean, but actually, I think that many organizations, that they're not turning their back on the cloud, but actually they want their IoT data and the analytics to be performed even in a classical on-premise way. So I think the message is you need a flexible way of deployment, whether it is cloud-based, whether it's right near the edge, whether it might be in a data center, which might be on-premise, or just a private data center. You need that flexibility in order to deal with, yes, some technical issues, but also issues around privacy, and issues around reliability. So what we're seeing is that it may be possible within a first project to pretty much centralize all your data processing. If we just take one manufacturing plant, for example, then the IT associated with that, you may just introduce get your data from your sensors within your plant, put it up into that IT capability, which might be internal or elsewhere, and then do the analysis on that. But as things scale, and as you're dealing with more and more data, then you've got to ask yourself, well, why am I taking it all up into one place? Because actually you might want to do some aggregation, some filtering, some statistical analytics on that raw data from your sensors close to them, and then you may then send the result of that up for further processing, and that might be a much more sensible architecture. Then you've got, well, actually with some perhaps complex devices, you might want to take some immediate action based upon the data that you're getting off there. You can do that localized. So maybe you want to adjust some parameters in the way that a machine is operating based upon the stresses on that machine at any one time to keep it working efficiently, to ensure that the temperature of certain components does not exceed a particular value, whatever it happens to be. That kind of analysis is best done at the edge. You don't need to aggregate it. So I think the line is flexibility and be able to deploy various parts where it makes sense. And maybe you start off deploying in a more centralized way, and then you push that functionality out to the edge as your system grows. But you don't want to have to reprogram. You just, it's a change in the architecture, but the fundamentals of what you're doing analytics on and that the analytics themselves don't change.
Yeah. And so that that actually highlights one of the things, in general with IoT is that there's a little bit of this misnomer that IoT means cloud, or like it's all about the cloud. Cloud provides incredible benefits. It's a huge component of one of the options here, but it doesn't have to be entirely about that. It's about the ability to distribute processing and storage where it makes sense. We're going to see a lot of different things, and it's just about having that flexibility based on the use case. It's actually kind of surprising how many people that have historically been doing connected solutions and for very good reasons locally are now talking about cloud, and it's like complete juxtaposition with how they've based their businesses to date. So it's having that flexibility overall. So Greg, from an IGAN standpoint, since you guys you're focusing on process data, but then also a lot of imaging data, which clearly consumes a lot of bandwidth, you have like an inherent need to do more edge processing, but then you're also using the power of the back end to create your algorithms. How do you see that from a manufacturing standpoint, and kind of deciding what to run where and those unique challenges? Like how do you guys work through those different considerations and determine how the processing is distributed?
Thanks, Jason. So I guess one of the biggest challenges is the sheer amount of data that we have to work with, and you have to take a selective approach in terms of determining what is of value to maximize the in-process efficiency, especially when it comes to quality control. So we primarily do deal with video analytics, and there's a lot of data. In the case of a single sensor for us might push 50 to 60 megabytes of data in a single second. So we actually think about it in terms of an asynchronous process. We'll go through a learning period with what we do to gather the data, analyze it, and look at data from multiple points of the production line and start to find correlations that can fine-tune an algorithm that can then parse out what you need to do specifically at the edge for a specific part of the process. So everything in manufacturing really focuses on one single point, but you can look across the end-to-end production line to try and maximize the efficiency out of that one single point. So that is inherently asynchronous. There's an asynchronous stage to that where you have to do the analytics and the advanced analytics across multiple data points to maximize what you want to do, filtering the data at the edge in real time, because as you say, there's an actual machine that you have to control and do it within a split second often. So the other way that we mitigate that, and what we see a lot in manufacturing, is a passive loop control versus closed loop control. So while a system is being tuned up and trained, you might be saying, training it by warning the operator, letting them know that there's a problem, and then once it's achieved a certain level of accuracy, then you can close loop it, and you start to stage out the controls that way based on your confidence in the system and how it's running. So there's a couple of different approaches there in terms of mitigating the risks with the processing power and maximizing it at the edge.
So kind of open it up for a training period, to a broader architecture, and then kind of close it back down for daily process.
Yeah.
So from a system integrator standpoint, with Action Point, when you do like in a smart manufacturing use case, for example, and you have a customer engagement, where in the process do you start kind of thinking about like where analytics are provided or performed? I mean, obviously, there's a lot about just what's the use case, what's the ROI, but how do you map that out as part of that overall engagement in terms of the technical side?
Yeah, it happens very early on. You can't ignore analytics. It's the kind of thing that is part of the conversation from day one. But what's very important is to bring the customer on the journey of understanding what do they mean by analytics. Because sometimes analytics is a simple dashboard, and understanding what is that use case from a data input perspective. And the framework we bring the client through is the notion that data becomes information, becomes knowledge, becomes wisdom. And analytics is that journey from data to wisdom. And organizationally, humans will only ever own the wisdom, but the other three, analytics is meant to help you out there. And the rule we have is essentially as early as possible. So much to your point, Greg, as early as possible, unless there's another reason to leave it go further. We will use analytics to get rid of the data and boil down information, because it's kind of ironic in that usually the more information you have, the less actual kilobytes you need, less megabytes you need. So it's information by definition much more concise understanding of the data. So whether that's putting simple edge filtering out there, simple compression algorithms out on the edge, or doing full-blown machine learning to understand what's going on and simply send a toggle switch to the cloud from a whole stream of sensors that are going on the edge. It's really part of that conversation, and those 4 steps, and that gives us the framework to get the client thinking without being bamboozled by, oh God, analytics and OR, and I got to have a PhD and everything else. It's really understanding the business value and giving everyone in the room the language to talk about it in a way that we're talking about the same thing and not talking across each other. That's a key challenge at the start of the project.
Yeah, that actually brings up, kind of the second topic that we wanted to touch on with everyone is just the inherent complexities of doing these types of solutions. There's some stats out there that basically today about only 1% of all data that's collected is actually analyzed, because there's just so much data out there, which is also the whole point of doing more as close as you can to the point of inception. But from what you guys are seeing at IBM, given some of these complexities, I mean, how much of it do you think is a technology problem versus more of a skills problem?
It's a good question. I think it's. Let me turn it around a little bit. Not necessarily a technology problem, not necessarily a skills problem, but an accessibility problem. I think part of what we're dealing with is analytics. Historically, you tend to think of IT and data scientist types applying analytics to data, looking at large volumes of data. As you get more complex, certainly. And I think our challenge is in making those analytics more accessible, right? Targeting a less skilled person, a less skilled data person, somebody who understands maybe the data and how machines should work, but doesn't necessarily have a PhD in data science, right? So it could be a technician, it could be the site manager, plant manager, it could be a line of business user, right? So I think one of our challenges is making the technology more accessible, and that fits right in line with, as we bring the analytics out to the edge of the network, we're exposing it to more people. The results, the insights that are gained, the actions that we want to take are interacting more with line of business systems, line of business devices, operations, and so we have to make the interaction with those analytics easier to use. And right, so some technologies like machine learning come into play there. How do we collect the right data? How do we train it? What needs to be processed at the edge? What has to be processed in the cloud? And then what do we do with the insights from the cloud? How do we feed that data back to the edge to update our analytics, the data we're collecting, the data we're summarizing or averaging at the edge, and then what data gets forwarded to the cloud? I think it's a learning and a continuous process. So I think it's partly tools and overcoming some of the OT, IT challenges, helping bridge that gap, as well as enabling the technology at the edge.
Yeah, I mean that's actually one of the things. You look at IoT solutions. I mean, connected solutions have been around for a long time. I mean, IoT really, as we look at it, represents that inflection point where things are just becoming more cost effective, more connected in general. The technologies are there, but also sophistication levels are going up to where operations groups are starting to feel comfortable or see the business value in connecting to IT systems, and so that's where that's really driving that convergence to get new business value. So kind of continuing on the human element theme of like kind of who does what, and how do you what are your thoughts from a software AG perspective between the operations group, the data scientists, wherever they may be, and the business groups and IT, and how all that comes together, and how do you make it work?
So you're right, Jason, that the IoT, this idea of in various domains getting physical information off machines, it's been around for a long time. We used to call it M2M, but it was kind of in its own silo. It was something different from general IT systems, and the Internet of Things is about fusing those together, where you've got the real world and you've got the conventional digital world, and it's getting value from doing that and opening up. You know, the IoT is opening up the possibilities, as you say, you know, making things cheaper and connectivity ubiquitous. So that then, this OT-IT thing, it is creating issues. So you've got, you know, I'm thinking of one particular customer, big chemicals manufacturer, and their operational people, their kind of attitude is, well, what's IT got to do with this? They run email. Why are they interested in what we're doing? And in fact, they know nothing about what we do. They know nothing about our data. So, you know, they've got these supposedly bright boffins, and they're analysing our data and telling us what to do with it. We don't like that. So there's that whole issue of trust, really. That's what it results in. And the demonstration that, you know, where is the value for perhaps skeptical operational technology guys about, okay, if they open up and allow other people that perhaps they wouldn't have interacted with traditionally to get at their data, to do analysis on it, to come up with kind of predictive and machine learning models that can help them do their job better and get some more out of the plant, for example, you know, in terms of operational efficiency. So I think that's going to be a continuing challenge, actually, with many more traditional forms of, in particular, say, manufacturing, in getting comfortable with the IoT and, you know, all their machinery producing data which is going off to some place, analysed by people that conventionally they haven't really interacted with.
Yeah, I mean, we're seeing too people, you know, being in the middle, like as sitting on top of a process does not mean you have to go deep into the process and change it. You can be scraping data and pulling it and doing business improvements without you know, actually, you know, causing risk of you know, bringing the process down.
Yes,
so
read only.
Yeah, so that's a common practice that we're seeing. We'll see as people get more comfortable, start to allow control to come down, but you know, it doesn't have to be that you're completely revamping everything that you're doing. You know, whether it's in a manufacturing space or in your building or whatever. It would be, you know, kind of, you know, tying it on top, driving new business gain, and then kind of building that trust level and the comfort. Is
and I think, you know, there's a way of looking at these things in terms of maturity. So you might start off saying, okay, well, what can the IoT do for me? So whether it's manufacturing or transport or, you know, healthcare, it might be, okay, if your operations today, we're not going to change those, but we're going to make them more efficient. We're going to, by giving greater visibility into that. And then you may have, okay, well, what can we do from a customer point of view? How can we improve perhaps the customization of a manufactured part? How can we give that customer greater visibility in the end-to-end supply chain, with perhaps manufacturing being in the middle, but other parts as well, logistical areas? And then you've got, okay, well, how do you actually then create new revenue streams from this data that you're getting? And that's the kind of slightly more scary one. And I think people are just, okay, thinking about it intellectually, but they need to start perhaps, okay, today, we know what we do as an organization, let's make that more efficient. And as we get comfortable using this fused world of physical and existing digital data, then we can move on to do more sophisticated things which will actually change what we're doing as a company. So the pithy comment, every company is going to be a software company, the IoT is going to drive that big time, because if people are not using the data that is inherent in their systems, others are going to overtake them.
So as you see, you know, kind of the IT and operations convergence that we're all talking about, and we're definitely seeing a trend here, from an Eigen perspective, kind of on the factory floor, how do you see that changing over time? Who does what? in a typical deployment?
So I have a couple of thoughts actually related to the conversation we're having about roles and how that I see that evolving. I think part of this is on us as practitioners of the IoT, where we're bringing a lot of technologies to customers that are still, especially when we get into things like machine learning and artificial intelligence, they're black box. So that causes a problem in terms of trust, where when you're dealing with an operational technologist, you're already coming to the table with something that is new, but then when you can't necessarily explain, well, why is it doing something a certain way? So I think the onus is on us a little bit to open the covers on how these black boxes are working, to start to build that trust on the floor. On the other hand, there is something working to our, I see these roles blending big time in terms of manufacturing. The operational technologist, the IT is becoming a function within OT is what we are starting to see. Certainly we have an aging workforce. Everybody has a smart device in their pocket. Everybody's starting to get used to the idea of mobility and smart apps and things like that. So the more that we bring some of these new technologies, the more that there's a generation of people that are going to be embracing these on the factory floor. That's certainly what we are seeing in our experience. And when you couple that with trying to create more transparency in the solutions that you're building so that there is trust inherent in them, so that a user feels like they have control, especially in the factory, I think I think we're going to see these roles blending and things changing quite rapidly probably in the next couple of years. I would think in 2 years we're not talking about OT, IT anymore. It's just one thing.
Yeah, I mean, we believe in a number of years we won't be talking about IoT anymore. It'll just be part of business. It happens to get a lot of web hits right now, so it's good to,
exactly.
good to talk about. But really, who says, "Oh, we're doing e-commerce now," or client server, or any other buzzword or whatnot. But it's a big inflection point.
I actually bubble it up, and I think about CTO versus CIO, and I actually heard someone telling me that they're starting to see more cross-functional roles within CTO. I'm a CIO role within the CTO or something like that. So,
so when you guys go and do an engagement with a customer, and we talked, kind of about the when is it the discussion on analytics start, and the answer is right away. Yeah. Who are you usually talking with, and kind of what's your take on this whole? Yeah, who drives the project?
Yeah, it's part of the same roles discussion, and it's generally the OT guys who drive the project. Like if you sit down with the IT guy to talk about IoT, you're going to talk about gateways, and you need a top-down view, not a bottom-up view, to get a successful IoT project. Those components are all required. Successful IoT requires all the different components, but you need to be talking at the OT level so you can understand what the business level drivers are, what's the key drivers going to run this project forward, and they're the only guys who really understand what's going on. And sometimes when we go in at a consultancy level, we might be asked, tell us how to improve your factory. How to improve our factory is what the OT guys be saying. We're like, look, if I walk your factory and make suggestions, I'm going to A, embarrass me, and B, annoy you, because you've already thought of all the easy things that I might spot, and you're not doing them for a reason. We always say that the OT guys have to come to us with a piece of grit. There has to be some pebble in their shoe that's actually wrecking their head. They have to identify the problem. They don't have a solution, but they know there's a problem. And we kind of use the analogy, we use the visual of a pearl, like a pearl with no grit in it is worth nothing, but the really, really good, valuable pearls have got that piece of grit in the middle. And an IoT project is like that. It'll always be shiny, it'll always look really cool, but unless there's grit in the middle of it all, it's worth absolutely nothing whatsoever. And we depend on the OT guys to bring that to us. And once we know what that grit is, then that drives everything end to end. When does your analytics happen? Is it early? Is it late? Is it deep? Is it shallow? Then what sort of edge processing do you need then to support the flow of data required to support your analytics? It just everything starts flowing from there. But unless you've got that starting point, that grit, you're just dead in the water. But then once you do start the analytics route and you're doing your filtering at various layers in the IoT stack, you've got to be careful, because if you turn the dial too high and filter too early, you're losing data. And if you've lost data too early, you can't get it back unless you're really smart and can infer it somehow. So we kind of, that's a balancing act. We always set expectations that once a project goes into production, that the dial will be maybe twiddled a little bit as we go along, just to make sure we find the right spot on the spectrum.
Yeah, I mean, that's a common theme. Giles, you mentioned it as well, is kind of starting with some sort of small point. I mean, if you go look at the things we're doing in the expo and with our blueprints, together with our partners, this is really a use case game and really driven around certainly, obviously, you're looking for ROI, but it's almost paralyzing the opportunities that you could do in this space. So you get to the point where you just don't know where to start, and then you got to find that just that kind of initial point, and then it sort of feeds off of itself. But building in that flexibility from the start in terms of how you can deploy things, or maybe even starting in one fashion and then kind of migrating over time to a different type of deployment. It's important to have that flexibility. So the OT-IT thing, Andy Rhodes, our GM, likes to tell this story. Is that he's had this deal where in an executive briefing, this big customer comes in, and it's Andy and these four guys come in behind him, and the CIO at that was there early says, "That's what I don't like about you Dell guys. You guys show up in these big numbers." And Andy laughed, and he's like, "Well, this is actually your operations department, you know." So they had never met before, so they met for the first time at the meeting. But it is about kind of starting to bridge the two different groups together and find new business value and opportunities. But so from a Watson standpoint, as you look at IoT, and kind of where you guys are headed, are any specific things that you guys think that you need to do to really handle the immense amount of sensor data that's out there? I mean, we've talked a bit about the edge analytics standpoint, but any other specific things over time?
I think the onus is really on us, as I mentioned before, to make the technology more accessible. We in the cloud, we're training Watson to do things like recognize video and image snippets, understand acoustic analytics, and recognize patterns in that, different sounds that you might hear in a house that represent security or safety risks, lots of different sorts of unstructured sensory data that we take in. And that's actually precisely the kind of data that tends to be extremely intensive on the edge, right? It's high volume. Somebody referenced, I think Greg referenced, some data sources produce 60 megabytes of data in a second or in a minute. That's video data, and that sort of stuff can be quite chatty. So as I think about where we need to head, we need to bring some more of that technology to the edge, make it easy to manage from the cloud, manage what kind of data you process at the edge, what kind of data you bring to the cloud, and enable some of our technology to run at the edge in the Dell gateways, right on premise, so that the results we're sending back to the cloud are just that. They're results. They're summaries and insights from data that are being generated close to the source. And then we can use those data points in machine type of analytics, right? It becomes a machine data point at that point, and I can say, I can recognize scenes, I can recognize sounds, things like that, and forward those as incidents or states to the cloud or to a rules engine or something like that to take some action on it. And I think at the same time, we've got to make the technology, it can't require a data science degree. I think the onus is really on all of us up here to make the data simple, to make the tools simple, and to make it transparent. I love that point you made earlier about we can't just bring a magic black box of tools and say this is going to solve all your problems, right? Because we as humans inherently, we want to understand, we're all from the show me state, right? We want to understand the results that we're seeing from analytics. And the OT guys, the guys out in the industrial operational environment, they're 10 times worse than the rest of us, right? They want to know why something is happening. Why do I need to change it? Why did you get these results? And we're all the same way. So I think there's an inherent need for the right tools to visualize and display the data, to explore the data, and to help our constituents understand what's going on in the data so that they trust the results that are coming out of machine learning, streaming analytics, predictive analytics, and all that sort of stuff.
So from a software AG perspective, I mean, clearly you guys, you have a strong focus on streaming analytics, things happening in real time, in memory, in the moment. But then there's that whole predictive nature, which tends to be more about, looking at the past and building models based on historical data. How do you see the two working together, and maybe how do you see software AG sort of adapting over time? And we know you have some predictive capabilities as well, but how do you see that changing over time?
Yeah, so you know, the streaming part of it is to say, okay, well, you know, in lots of different domains, but the IoT is a great one, where you have all this data coming at you on a constant basis. If particularly you want to take some decision making on that instantly, you know, adjust the way that a machine is operating, perhaps you want to get greater yield from your production line, then you need to be able to examine that and take a real-time decision on it. So a conventional method might be to say, well, let's take that data and we'll, you know, either shift it up to the cloud or, you know, put it into some other system, and we'll look at that afterwards, and we can retune the system in the way that it operates when we've examined it offline. And that's still useful because you need to perhaps come up with predictive models. So you need to train those models, and you need a large, preferably, corpus of past data in order to do that. But once you've got that predictive model, then you need to operationalize it. You need to put it into production, and you need that predictive model to start making predictions. So that's where it can sit inside, if you like, your streaming analytics engine. You're flowing this data over the predictive model, and then you can instantly make a prediction, perhaps that there's going to be some catastrophic failure in a machine, or that you need to tweak the parameters of something to get it to be running more smoothly, so you can avoid a failure or you can get most out of your asset. So we're seeing now the execution of predictive models, whether those be decision trees or whether those be neural networks, whatever they are, that you do your offline training. That has to be offline. You're never going to do that online, I don't think. That's going to be quite brave of somebody to do that, because you can't go through the QA processes that you need. You do that offline, and then you put it into production. And then you can gradually evolve it as time goes by. I think just sort of one comment on this transparency into the data. I mean, yes, I think that's a good sentiment, but with many types of predictive model, you know, whether it you know, deep learning model in particular, which of course are getting, you know, we're getting some real, particularly in image processing and other things of fuzzy analog data, we're getting some real improvements there. It's actually very difficult to be able to articulate, well, we've trained the system on this, it seems to be coming up with the right predictions. We don't really know what's going on inside, because that's the inherent nature of the technology. So there's a limit to what you can do. But you know, in the same way that no one questions about how a piece of hardware works, or how actually, well, how does Wi-Fi work? You know, I really need to know that. So although there might be skepticism about, okay, well, you know, we're getting inputs in here and it pops out a prediction. How does that work? Over time, people are going to have to trust what the machine is doing, and I think if they feel that there's the right process has gone through to come up with that model and to QA it and evolve it, then people will have confidence in the data and the modeling around it.
Yeah, actually, to that point, one of the techniques we use when we're building predictive models is we'll take a data set from a customer, let's say 6 months of data, and we'll use 4 months of that data to train the models. We'll look at incidents and failures and things that happened over those 4 months. And then we'll build our models. We'll look at several variations, we'll tune it, and try to make it as accurate as possible. And then we validate the model against the last 2 months of data, right? And that's a technique that we use, it's probably fairly common, to just gain the trust of the people we're selling the analytics to, and give them some confidence that the analytics work. It's not a complete black box. We can at least show you the results and give you some feedback, right? And then we use a broader data set, and you know, things progress. But the idea of starting and you know, proving along the way incrementally and gaining buy-in and growing sort of the adoption and the confidence in the analytics, I think, is critical.
So how often do you see the retraining happening? Is this just an ongoing, continuous process, or do you take it offline, go do it, run it for a while? I mean, how do you know when you've got it good?
I think there's a couple of metrics. You guys may have other opinions. I mean, we look at the quality of the predictions, right? And there's two facets to that. There's the accuracy of the prediction. How many times am I catching the failure or the incident? Is it 95%, 98%, 100%? And then there's the lead time, right? And you sort of trade those two off against each other because you can't be 100% accurate and get 6 months of lead time all the time. But you try to tune those to what makes most sense for the use case. And our false positives okay sometimes, then I'll be a little aggressive in the model, you know, to be safe. But you know, that's sort of how we think about it. And the retraining happens as you start to see too many false positives or false negatives, and you get to a point where you know, you're not comfortable with the model. And I think I'd like to think we could get to a point where we could automate some of that, but I do think there are going to be humans involved in that retraining and the validation of the model. I think it's going to take us some time to get you know, a vision that I'd like to be at. But what we're trying to do is capture in some sort of automated fashion with a little bit of human intervention when the model's producing good results and when it's producing bad results. And then use that as data points to decide when we need to go retrain the model.
Yeah, and you can even use multiple models at the same time. So you can come up with multiple models with, you know, different fundamentals, different principles involved, different parameters. Let them run concurrently, and then almost use an evolutionary process to, over time, tweak them a little bit, and one will hopefully come out as the winner.
So I mean, you mentioned the human element, and from a you know, having people involved. A big part of what you guys do is I mean, you harness the power of trained operators, people that have been on the manufacturing line for, you know, 20, 30 years or however many years it may be, to help you know, hey, yeah, that's good. No, all hell's breaking loose when that happens, you know, from a standpoint, and train those models. But we also have an aging workforce, as you had referenced, and you know, fewer going into skilled trades. Do you see artificial intelligence eventually starting to, you know, kind of fill that gap over time?
Yeah, I mean, we look at it slightly differently. When we think about the factory floor, I mean, the factory floor is really, that is the edge, and it's made up of a community. It's a community of operators and people working on that floor. And that community has a collective intelligence. And there is the challenges we have around aging workforce. The other big challenge is turnover, because the replacement workforce that's coming in doesn't stay at the same place for, you know, more than 4 or 5 years, whatever. So this intelligence is walking out the door. There's a lot of legacy that, you know, just disappears, kind of thing. So when we think about artificial intelligence, we don't think about it as a control layer so much, and again, some of this is sentiment, but we think about it as a collaborative intelligence. So it's also an agent along everybody else within that collective and that community, and it's giving advice and it's taking advice. And the way that we do that in our solution is we're harnessing the input from operators and use that as a layer, a data set or a data point inside the machine layer, with all the other data sources that we've gotten from the factory line to augment the intelligence of what it is that we're doing. So the benefit of that is that you also build the trust with the operator of the factory floor and that community, and it starts to become that agent over time. So you know, I really think about it as enablement and a collaborator of the process as much as anything.
So from a, you know, I mean, Action Point's been doing business, you know, historically, kind of from the IT standpoint, doing services into, you know, on the IT side, networking and deploying full infrastructure for companies. Have a lot of skills that are very applicable to IoT, but, you know, also imagine there's some new skills that you guys need to add. Can you give us kind of a flavor for what? Where you're expanding and how you see your skill sets needing to transform over time to address these use cases?
Yeah, certainly IoT disrupts the client business, but also disrupts the vendor's business. And I think one thing we're all getting used to is longer lead times on sales, for sure. But like within the organization, as you said, we're fairly unique from a software development perspective in that we have enterprise-grade software development and IT services in the one organization. You have a lot of MSPs that do a bit of software, a lot of software that does a bit of IT, but we've got the two at the enterprise level. So we were used to dealing with the physical world as well as the software world. But when it comes to IoT solutions where your hardware actually ends up out in the field in a fairly aggressive environment, that's a step beyond the data center. So certainly one learning curve is just dealing with the world of sensors. And one of the first deployments we did in a factory, we would like hunt around forever to find a really good temperature sensor. We did a lot of testing on it. It was like A1. We're like, okay, we'll take your humidity sensor too. And he goes, oh no, humidity, that's completely different altogether. We don't have humidity sensors at all. So it was just this highly specialized area that was a complete eye-opener for us, being a software generalist, you know. So yeah, the sensor world, understanding what sensors need to go where and how to get the connectivity back up is a big challenge for us. And then on the other end, on the analytics side of things, you know, the tool sets, there's a plethora of tool sets out there for doing analytics. And going back to my very first comment, the challenge you often have is clients really don't need heavy-duty analytics. They're just looking for a pretty dashboard. And so just understanding that and making sure we pick the right tool for the job, and we don't go OTT, but we also don't under-spec. So there's a lot of a big learning curve there just on third-party tools to bring into the solution. Then beyond that, like, you know, the bit in the middle, the software itself is pretty much the same. Once we get data reliably from a source, you know, we sometimes joke, we'll start at MQTT, we'll start at the digital stream of data from a device. If we have that reliably, and then everything from there up to the cloud is just straightforward software engineering. It's not too difficult. But the real learning curve and the real challenge for us has been that software we used to build before used to live in a bubble, in an enterprise network, in a data center, generally used by staff or customers with logins who you could control. And now all of a sudden we're sticking sensors on horses and hoping to God we get the data off them in a reasonable time frame. So it leads to very different support calls, very different operational activities. And yeah, so they're the challenges. It's more the operational challenges around delivering into the physical world that you just, as a software guy, can just upload something to the App Store, next thing it's deployed to 1,000 phones without touching them. It's a very different world in IoT, a very different world.
So I had a question for the group. I mean, so we talked quite a bit about trust and trusting data and the models and whatnot. And so, I mean, I would argue that Internet of Things is a total misnomer. There's never going to be like everything possible, all talking to everything out there. It's really a series of increasingly larger intranets that start to connect. And as you find new business value, you'll have, and you get kind of past some, even in some cases there's competitive things, there's the risk of exposing dirty laundry when you're really a lot less efficient than you should be. So there's some of those challenges that there's a comment about, you don't want to point out some of the problems with, from an operations standpoint, because it kind of can make people, expose something was wrong. But as companies start to find new business value to connect, how do you trust one another's separately determined results, and how do we get to a point where people can actually share data and believe the data that, it's one thing if you trust it within your own organization. It's another thing if you have to trust someone else's input and someone else's input to come together. Any thoughts on that? Kind of, how you
depends whether it goes via the marketing department.
Yeah.
It's a difficult one. I think, like, if you layer inferred data on inferred data on inferred data, your deviation grows exponentially as it goes. So if you're taking a machine learning output, whatever the phrase is for that, I'm sorry, and then you're taking 3, 4, 5 of them, and now you're coming to an inferred conclusion from that layer, and even going layer again and again, you're getting further and further from the real hard data, and it is really a question of trust. And I think the real challenge, if you look at autonomous driving, the real challenge with autonomous driving, the joke is that the danger to autonomous cars is not autonomous cars, it's non-autonomous cars, it's the human driver. And the problem you have there with trust is the cultural expectation is when you're comparing an autonomous car against a human driver, you're not being compared against a human driver, you're actually compared against this unbelievable notion of perfection. And it's the same thing as, like, if you're in a machine learning environment, you might say, well, it's 98% accurate, but those 2% of the time you're going to get a call and someone's going to be screaming at you. Yet if it's an operator and they get it wrong 2% of the time, it's like, well, that's part of the metrics that's built in. So there's a very different expectation on what machine learning can deliver.
Yeah. So there's an accountability issue there, isn't there?
Yeah, very much so, very much so. And that's the other big blocker for automated vehicles, because it will ultimately be the manufacturers that have to take on responsibility.
Well, the problem there is you have to hard code in a choice. Like, if you're going to hit this, a lady with the stroller, or like run into a tree, of course, you would program, run yourself into a tree, and then it probably cause harm to yourself.
No,
you gotta
only
mark it
every
in.
time.
Or do
Sorry.
you just make it kind of a random? Do you randomize it somewhat to bring in some of a human element? I mean, that's one of those big things too on the AI side is a whole other world of legal issues and
yeah. But I don't think this is really an IoT issue. I mean, if you think about, let's take a manufacturing plant and robotics on the shop floor. I mean, I guess we could make the same point about, well, do you trust the robot to do the job properly? And where's the accountability there? And rather than a human operator perhaps doing something by hand, and I guess you get to that point of trust by deploying something in a specific scenario. It does something in a repeated way, and over time you think, well, actually, 99.99% of the time it's doing the right thing. That's good enough. And with a data view of the world, then we're going to have the same questions. Is the fact that perhaps we've moved that operator on to do something we might think of higher value, and we're giving the autonomy to some software to take some decisions about how to tune the way that a machine works. So is that working or not? And over time you get comfortable with it. Yeah, it seems to be working. That's we've elevated everything that we're doing, and we can then allow the humans, the wisdom to come in to take those perhaps more strategic decisions, and we've automated some more decision making. So I don't think it's something that we haven't encountered before, and I'm sure we'll get there.
Yeah, we're just scratching the surface here, but I mean it goes back to you start with a very, very simple business problem to and I like to talk like let's talk more about smart departments than smart cities. Get very focused on how can I make stop running trash cycles endlessly around here? How can I make particular areas safer? Or how can I help out with a particular portion of the traffic system? But
one way to start, you made the point yourself, Jason, that if you've got all this data surfacing, it doesn't have to be about, oh, right, well, let's take that and let's start making actionable decisions on it immediately. It can just be about visibility. And that might be, well, we are going to give more visibility to our customers about what's going on with their the operations that we are sensing, whether transportation, manufacturing, whatever it happens to be. Let's give them more visibility into what's going on. And we can put that information that we're getting from the IoT together with existing customer information that is in our existing IT systems and join it all up. So that's a win for customer service without actually changing perhaps the way that you're operating underneath.
So, yeah, I mean, the trust factor too, it seems like maybe as you have more and more use cases out there of similar kinds and more people willing to share data, you can start to corroborate, get to a lowest common denominator, even though the similar answers achieved from completely different systems, and that's going to start to increase the trust level.
I always think about the visibility that we as consumers now expect when we order something online. We even go when we do research on it. Reviews, pricing, inventory. When we order it, then we want to know when it's going to be delivered, where it is. Is it out being delivered for delivery now? That's extraordinary compared to 10, 15 years ago. And if we use some of those same principles with business customers and the kind of visibility that perhaps they would like, that's where the IoT can provide some real benefit.
Cool. So we need to wrap up here. Any quick questions from the audience? From a overall IoT perspective, the notion of distributed analytics.
It's all over the place.
It is like
It's all over the place.
Yeah, it's
like the language probably is OR for really deep analytics. You know, but a lot of the tools support OR. You've got high-end stuff like Statistica. You've got basic stuff like Tableau. It comes down to whether you just want visualization or analytics, and they're two very different things. They look like they're the same thing until you try to do one with the other tool, and then you go nowhere. So really, it's you know, how many different brands of hammer are there out there? There's lots of different brands, and it's the same thing. But whether they do different things, they do subtly different things. But ultimately, it's down to who wields it. That's really what it's about.
Yeah, I mean, I would say there are two big beasts in the analytics world. There's IBM with SPSS, and there's SAS, and then there's a whole load of smaller vendors. None of whom I would say have got critical mass in terms of the design of models. And you know, an issue is standardization, and there's something called the Predictive Modeling Markup Language, PMML, which is supported by some, which we're a big supporter of, because you can take any PMML model and then put it into our software and it'll run. And that's one way of dealing with this issue, but it's still not supported by some, but not everybody.
Yeah, I would echo the same thing. I see a lot of fragmentation in the space. Even though we have some good tools, we run into lots of people who don't use any of our stuff. You know, but what I would add is we're starting to see, we had the reference to R, you know, tools like R and Python and Jupyter notebooks. We're seeing some open source types of tools that I think are great for certain types of analytic patterns, exploring data, building models, and there's pretty extensive libraries that are out there. So there's a lot of cool things you can do just by, you know, grabbing some of what's available with R or Python or a Jupyter notebook and leveraging that to just start exploring your data, understanding, you know, visualizing it in different ways, looking for anomalies, trends, correlations in the data, and some things like that. There's some really powerful tools out there. Now, some of it's not for the faint of heart. You know, you got to be able to program Python or R. You know, you got to have a little bit of data science skill to go do it. But I have no data science training, and I can get into a Jupyter notebook and kind of get around. I have no Python training, but I can update it because I know Java or wrote C or C++. So, you know, I encourage you to, you know, take a little bit of a look at some of the open source tools too.
Yeah. Don't be afraid.
There's one other thing I'd add to this, Jason, which is back to the IT OT thing, and this is something purely observational that I've noticed. I'm happy for anybody to call me out on it, but when anybody's coming from an IT type of background, when you think about analytics, you're thinking about modeling and you're thinking about visualizations and you're thinking about reports. When I talk about analytics with operational technologies or factory floor people, they don't think about that. What they're thinking about is what's the real-time decision. That's analytics for them.
Yeah.
It's analyzing and doing something. So the terminology is slightly different depending on who you're talking to there.
And I would, yeah, so, definitely too. And you stress the trust factor is, you know, we're big believers in, you know, open source really being a key part of IoT and that whole notion of some of those tools and certainly standards, but also the tools from being open where it matters to help build that trust level, because people are starting to use some more kind of common, you know, baselines. We're also, you know, big believers from the same standpoint, from a data interoperability standpoint, is getting some right open source tools out there. So. So we gotta wrap up. I mean, I would encourage you guys, if you haven't already been down to our IoT Expo, is to check it out. You guys will all be kind of around. We'll have,
it's very
you know,
exciting.
Yeah, stick around. It's
lots of toys to play
get
with.
get some ice cream on
Free
top
ice
of
cream.
that.
There's ice cream as well.
You know, the intent was to show how, you know, all these different use cases and throughout an entire life cycle sort of can kind of come together and start to relate in the bigger picture. So definitely check out the expo down on the floor for IoT. You know, just kind of, you know, sum up, you know, obviously, you know, we're here to be the backbone behind these solutions, highly focused on partnerships, you know, with the folks here and others. But, you know, this is going to be a ecosystem game. There is no one size fits all. It's all about working with people and sharing collective knowledge and just going solving problems. And another big part of this too is that you can see, you know, both in talking with the teams downstairs or on our website, is that we believe strongly that this is also about building out, blueprints and reference architectures and showing, how that ROI is developed, and then building out case studies and getting people to really understand, just to take that first step, or find the grit, so to speak. But so that's what it's all about. It's about let's all kind of work together and go figure out how we make things better. So thanks for listening, and thanks for participating. And
Thank you.
Thanks, Jason.
Thank you.
Catch you all later.
Thank you.
All right. Thank you.